Let me tell you, I run a free online SAT prep community, and I frequently ask the people in there, which section of the SAT are you struggling with the most right now? What do you think is the answer they most commonly give me? It's not Desmos regression, it's not reading passage questions, it's math word problems. I know that might sound crazy, but the truth is almost everybody struggles with these types of questions at some point in their SAT journey, because they are pretty hard. They involve two of the worst things: math and words. Bruh. So in this video, I'm going to explain to you the exact strategy on how to approach these questions and literally everything you need to know if you want to master them really quickly. I'm literally making this video so I can just send it to people who are struggling with this concept. So I'm putting in everything I want them to know, all for free. You see, to solve a word problem like one of these on the screen, you need to do 4 different things. And if you skip a single one of these, you're basically screwed, I'll be honest. 1, determine what the question is even asking in the first place. 2, determine what the variables represent. 3, make the equations. And 4, solve the question. The issue is a lot of people skip directly to step number 4, which is why they struggle on these questions so much. Because you need to be doing step 1, 2, and step 3 in order to actually get these questions right and understand what the frick is going on. But first, let's talk about linear word problems. You see, linear word problems on the SAT always follow this exact format, or at least most of the time. Y equals mx plus b. When you see an equation like this on the SAT, keep this exact thing in mind. Like, you can basically copy this word for word when you get to the SAT. The y is the total amount of things. Whatever they're talking about as the total amount, whether it's the total amount of money it costs or the total amount of materials being used, that is what y represents. M represents the rate of the function. This is how fast it's either increasing or decreasing. So for example, if every single individual item costs $3, 3 would probably be the rate because every single additional item adds $3 to the thing. X is the input. It's basically the amount of things you're putting in. So maybe it's the amount of items you're buying. And then finally, B is the start value. This is the amount that the total will be if X is equal to 0. So if you're buying nothing additional, if you're not doing anything else, this is just the straight up amount you'll have. But I know this probably makes absolutely no sense without an example, so let me actually show you one so you're not just confused and sitting there watching skibbity toilet rails. Bruh. A roller coaster starts 15 feet above the ground and rises 8 feet per second. What's its height after S seconds? Well, we have Y because we just kind of have to have that. That's the total amount. And then it says it starts 15 feet above the ground. So we basically know that that start value here, B, is going to be 15. So I'll just put that right here at the end. And then it says it rises 8 feet per second. So 8 feet is the amount it increases every single time. So we put that. And then for the variable here, it uses S instead of X, but that's completely fine. So we can just put S there. So Y equals 8S plus 15. A plant grows 1.2 centimeters per day. After 12 days, it's 36.8 centimeters. How tall was it at the beginning? This might seem a little bit more challenging, but it's not actually too bad. So we're trying to figure out how tall it was at the beginning. So essentially we're trying to figure out the start value of the equation. And the information that we're given is 1.2 centimeters per day. So that's basically going to be the rate. And we also get given the total after 12 days, which was 36.8. So essentially 36.8 must be equal to 1.2, because that's the rate, times the amount of days, which is in this situation 12. And then we're just trying to find what B would be equal to. I can literally just put this exact equation into Desmos because I'm not a GigaChad, and the answer is going to be 22.4. You also can see linear equations in these word problems like this: ax plus by equals c. A is the value of x. When I say value, that typically means something like price. So X might be a certain thing you can buy from the store, and A is probably going to be the amount that that thing costs. X is then obviously just the amount of X, it's the amount of the thing that you're buying. B is the value of Y is the amount of Y, and then finally C at the end is the total amount. So a pretty common example of when you'll see this is if you're trying to figure out how much a purchase will be at the store. So maybe you'll find out that A is equal to 3 because it costs $3 for item X. And then B is equal to 5 because it costs $5 for item Y. And then you're just trying to see how much you can buy of each item to get to, let's say, $20. And it'll be a certain amount of X, a certain amount of Y. But we'll cover this a bit more in the systems of equations thing in a second. Now, a very common thing, the SAT puts this all the time, and so many students look at this and then they struggle and they think, oh my gosh, I don't know what to do. And then they run away and then they cry. First day costs X. You can see problems where it says something like, you're providing a service and it costs a certain amount the first day. So it might be like Y equals $100. But then it says for every day beyond the first day, it's going to cost $20. In order to show that, all you have to do is just add the additional rate. So we would add $20 and then do x minus 1. Think about why this works for a second. You're having the 100 here, so that counts for the first day. And then it says x minus 1. So if you have 5 different days, the first day will be counted by the 100, and then the next 4 days will be for this x minus 1 thing. And that's counted because you have x minus 1. Don't get messed up on those. These happen a lot, but it's not that bad like I'm showing here. Systems of equations. So you'll see situations in these problems where there's 2 separate things you have to keep track of at the same time. You'll know it's a system of equations problem because you'll just kind of notice that it feels a little bit more complicated than these other problems. And oftentimes what happens in these problems, I'd say basically every single time, is that you have to make these 2 separate equations. The first equation is items plus items equals total items. Like we were saying before, x typically represents the amount of items, and y can also represent it. So it's usually x plus y is equal to some number. And then you have the value plus the value equals the total value. That's usually represented by this equation here, ax plus by equals c. So you're saying the value of x with the price of it times the amount of it is equal to some total amount. And then if you put these into Desmos, you'll actually see something like this. You'll see 2 lines and they intersect each other at one place. And this one place where they intersect is the solution. Let's try an example like this. A concert sold 150 tickets, general is 40, VIP is 100, total revenue is 8,400. How many VIP did they sell? Okay, so let's try to keep track of what everything is saying. We have 150 tickets, so that's the total amount of tickets being sold. Then you have the total revenue, which is 8,400. So that's basically the total value we're producing here. So we can say G for general plus V for VIP is equal to 150. And that just makes sense because that's the amount of tickets that they sold. But then we have to have the value. So we know that general is 40. So 40 times G plus 100 times V is equal to 8,400. This looks simple enough. Now let's put it into Desmos and actually solve it. All right, I put it into Desmos like this. I had to change the variables to x and y because that's what you have to do in Desmos. If you don't understand why I had to do that, watch my Desmos video. What are you even doing at this point? But anyways, the answer here would be 110, 40. So since 110 is equal to the general and 40 is equal to the VIP, the answer would literally just be 40 in this case. So they can sell 40 different VIP tickets in order to get to this certain amount. Okay, we're almost done, which should make you very, very happy. But there are 2 different types of equations we have to just briefly go over. First is quadratics. So sometimes you don't have things as nice as you want it to be in life, unfortunately. Sometimes rather than just a straight line, you have some monstrosity like this garbage on the screen right here. A curved N-shaped line, you could say. And when this happens, that means it is represented by a quadratic function. The main thing you're really trying to look for in a quadratic is this squared thing. When there's a squared, that typically means it's going to be a quadratic. I gotta be honest, the main example for this is when you're throwing a ball in the air. So you'll often see problems where it's like this is the time down here, and then this over here is the height of the ball. And so it's just trying to show how when you throw a ball upward in the air, it will get to a certain point and then fall back down. I know it sounds kind of cringe. I know you're probably thinking, out of all the things that the SAT could include, why would that be the thing that they would go with? I'm wondering that too. But this can be shown on the SAT, and so you just gotta know that it's gonna work out like this. You don't really need to know what any of these different variables mean. You just really need to know how to use this function. It typically involves using Desmos as well, so don't really worry about any of the other stuff like C, B, A. You don't really need to know what any of those mean. They don't have like a very simple explanation like they did for this stuff up here. And then finally onto exponents. So this does have kind of a formula. Y equals AB to the X power. Y is the total again. A is the starting amount of the thing. So, it's the very base thing. Then you have the rate of increase or decrease. So this is essentially the growth factor. And then finally, X is the number of time periods. So a population starts at 500, increases by 8% per year. What's the population after 3 years? So Y would be the total population. And then it starts at 500, so the starting amount would be 500 here. And then it increases by 8% per year. So in order to show that, we have to have the growth factor as 1.08. It has to be 1 because it's saying it increases by that amount. If it was just saying decreases by 8%, then we won't have to have the 1. And then finally, we just have X over here. So what is the population after 3 years? Let me just put this into Desmos and put 3 in for X and see what it gives me. Okay, it's 629.856. Since you can't have part of a human, you just have to say 629. Okay, then we have a car worth $20,000 depreciates by 15% each year. What is the value after 2 years? So $20,000 is the original amount and 15% is the amount that essentially changes each time. So we can say Y is equal to 20,000, and then 0.85 because that's the amount it decreases by, 15, and then 1 minus 0.15 is 0.85, and then each year would just be X. The answer would just be 14,450. Nice, that's awesome. Inequalities. Yes, we also do see problems like this on the SAT. The way this works is essentially the exact same as the linear stuff that we were showing back up here. The only big difference is that now we have to use an inequality sign rather than an equal sign. And you'll see different things in problems to show what inequality sign you have to use, but you can just use this simple graphic on the screen. At least is greater than or equal to, at most is less than or equal to, and then you can read the rest on the screen here. So look at this example. You earn $15 per hour and already have $20. How many hours to have at least $200? So essentially 15 per hour, that would have to be the rate of change, and already have 20, so that must be the starting amount. And so we must have at least $200 at the end. At least is right here, greater than or equal to. So we can say 15 times H, and then plus 20 because we already have that. And then at least greater than or equal to 200. So what does this H value have to be to make it at least equal to or greater than? If we put it into Desmos, you'll see that the entire thing is shaded. I explain more as for why this is in my Desmos video again, but all you really need to know is that, okay, it has to be at least 12 hours in order to get to this 200 number. And anything above 12 also would be counted. So 12 would be the answer. But you can also have systems of inequalities. This may sound like it's complicated, but again, it's basically the exact same thing as the linear stuff, just with inequalities instead. A student buys X notebooks and Y pens. Notebooks cost 4, pens cost 2, budget is 30, 3 notebooks, 5 pens. So essentially the rate of change here is 4 for the notebooks, 2 for the pens, and then it has to be 30 at the most. So we can say here, X, which is notebooks, must be at least 3. So at least if we go back to this thing up here, okay, yeah, greater than or equal to. And then Y, it must be at least 5. So then greater than or equal to 5. And then says the notebooks cost these amount, and so the budget is at most 30. At most is less than or equal to. So it would be 4x plus 2y is less than or equal to 30. Now let's put this into Desmos. So again, you'd already know this if you watched my Desmos video, you absolute disgrace to society. Bruh. But the way to find out the answer to the solution is just looking for the place where they're all shaded. So the blue, black, and red is all shaded in this little triangle type thing over here. So anything in this triangle will be part of the solution. So I guess you could say they can get between 3 and 5 notebooks, and they can get between 5 and 9 pens, and then it's all good. Finally, let's just go ahead and solve some of these problems. There is a couple things I wanted to show you though, as for easier ways to get through some of these different word problems you'll see on the SAT. A museum's membership decreased from 18.4 thousand in January 2015 to 15.2 thousand in January 2023. Assuming the membership changed at a constant rate, which linear function M best models the membership in thousands t months after January 2015? Now you may be thinking, how am I possibly supposed to do this problem? But there's actually a really easy way to do this. If you just go here in Desmos, you can make a table, and then you can put in the 2 different values it gives you. It's saying it was 18.4 thousand on January 2015 and 15.2 thousand on January 2023. And it's saying that this is the amount of months after January 2015. So there are 8 years between January 2015 and January 2023. So if there's 12 months in each of those 8 years, simple math, it would be 96 months. So we can literally just say 0, 18.4, and then 96, 15.2. And then we can go ahead and click here, and it gives me a equation for this, negative 0.0333 plus 18.4. Now, unfortunately, we get given fractions for all these, so I can just go here and say negative 0.033333, and then we find out that, and then click on this, and it gives me 1 over 30. Okay, so this part has to be 1 over 30 and has to be negative as well. So it can't be this, and it can't be that. And then what does 18.4 equal? Well, if we put 18.4, then we click that, it gets 92 over 5. So therefore it must be A. So I'll literally just use Desmos to basically do that exact problem for me. So kind of amazing that you can just do that, and this makes a lot of these problems easier than they would be otherwise. Bakery A sells croissants for 2.5 each and muffins for 1.75 each. Bakery B sells croissants for 3.2 each and muffins for 1.3 each. A certain order of croissants and muffins would cost 22 at Bakery A and 24.4 at Bakery B. How many croissants are in this order? Okay, remember that process from before. So let's understand what each of these variables are saying. So 2.4 is the amount for each croissant. 1.75 is the amount for each muffin, and then we have the amount of croissants and muffins shown by here. then it's saying bakery B has this for each. Okay, so it's like two different bakeries going on here. Each one has a different price for each thing. And then it says cost 22 at bakery A and 24.4 at bakery B. So we can go ahead and do A, and that would be croissants 2.5, then muffins for 1.75. And then B, it's croissants for 3.2, and this one, it's got muffins as 1.3. So I think let's just put this in standard form, honestly. So we can just say 2.5 C plus 1.75 M is equal to 22. Then for the other one, it can be 3.2 C plus 1.3 M is equal to 24.4. And then finally, let's just go ahead and put this in Desmos. Alright, we see here the answer is 6-4, so we're trying to find out the amount of croissants in the order. Croissants is represented by C or also X in here, so it'd be 6. The answer would be 6 croissants. A fundraising committee is selling two types of coupon boxes, standard and deluxe. Each standard book brings in 12 in revenue, each deluxe brings in 18 in revenue. Wow, they're really making bank here. The committee must raise at least $12.60 to cover its costs, but can print no more than 100 books in total. If X is the number of standard books printed and Y is the number of deluxe books printed, which system of inequalities correctly represents these constraints? So let's figure out the variables here. 12 is for each standard book. Meanwhile, 18 is for each deluxe book. They must have at least $12.60 in revenue for what they need, and they also cannot do more than 100 books. So this is a pretty clear example of inequalities. So we're saying here 12x plus 18y must be less than or equal to 1260. No, it must be at least 1260. It has to be greater than or equal to. So therefore A just can't be right. 12x plus 18y greater than or equal to 100. No, 100 is the amount of books. We're trying to look at the price for this one because that, remember, that's how, if you go back to the stuff up here, the value plus the value equals the total value, and then the items plus the items equals the total items. 12x plus 18, okay, same problem here. So we know it has to be D, but let's just make sure. 12x plus 18y is at least 1260. Okay, yes, that's right. That's the total amount of money. And then x plus y is not more than 100. It's less than or equal to 100. So therefore D would be the answer. Now, I feel like I say this in basically all my videos at this point, but the truth is this video is not enough. You cannot get everything you need to know about how to do SAT word problems just from watching this video. You have to actually do a lot of practice with this. And especially if you're kind of bad at reading, or especially reading problems on the SAT, you might have to give yourself extra time to be able to actually understand how to read these problems and how to make sense of it in your mind. Anyways, that's it for me. Comment below what video you want to see next.
This at SAT, yeah, it's pretty mean. Trying to judge my whole life off of tests on the screen. One shot, one run, no pause to rewind. If I panic, I'm done. If I trust, I'll be